After a long wait of 25 years, several budget overruns, and unprecedented delays, James Webb Space Telescope was finally launched. The Hubble Space Telescope opened up new windows on the universe, but scientists expect that James Webb will reveal even more, revolutionizing our understanding of the cosmos and perhaps bringing us closer to answering the age-old question: are we alone in the universe? Welcome to the Discover Space channel, where we uncover the most fascinating cosmic truths and explore the universe together. According to NASA, the James Webb Space Telescope will focus on four main areas: first light in the universe, assembly of galaxies in the early universe, birth of stars, and protoplanetary systems and planets. It will make many maneuvers and course corrections in the first month to reach its final orbit around the L2 point, and the alignment of mirror portions will begin in the second month. The primary mirror segments may take 60 to 90 days to align and work together as a single optical surface after launch. By the end of the third month, Webb should be able to take its first science-quality photographs, as well as finish its voyage to its L2 orbit position. For the time being, it will only be taking hazy and blurry photographs, potentially of bright stars, for the sake of optimization. So the next few months will go into calibrating and optimizing its cameras and other instruments. Finally, 6 months after its launch, Webb Cycle 1 observations that range from searching for atmospheres on nearby rocky exoplanets to investigating the universe's oldest galaxies will begin. Webb will be able to see through vast clouds of space dust that block visible light to reveal previously hidden secrets of the cosmos, such as early galaxies over 13.5 billion years old and the development of stars and planets, by sensing infrared radiation, which can be detected as heat. Thousands of the earliest galaxies produced within a billion years of the Big Bang will also be studied. Because these galaxies are so faint, they have always been out of reach of existing telescopes. Webb, on the other hand, can see considerably fainter objects. As a result, it is projected to provide a wealth of information about the history of the universe, particularly about the time period between 400,000 and 1 billion years after the Big Bang, when the first stars and galaxies emerged. The James Webb Telescope will use its massive mirror to see the worlds as they transit their host stars, blocking starlight as they pass in front of them. The researchers will be able to determine the basic structure of any atmosphere present mainly on the super-Earths and sub-Neptunes. With this telescope, scientists can detect water, carbon monoxide, carbon dioxide, and methane in atmospheres of Earth-sized planets. While these aren't conclusive evidence of life, they do raise intriguing issues, such as what caused the methane and carbon dioxide to be formed in the first place? Is it possible that life existed there? TRAPPIST-1, a transiting planetary system roughly 40 light-years from Earth, will be the most fascinating planetary target. The system's second innermost world, TRAPPIST-1c, is regarded to be too hot to support life. As a result, Webb will determine the temperature of TRAPPIST-1c in order to determine whether or not the planet has an atmosphere. This isn't the end of the planetary observations. Aside from researching other worlds, Webb will conduct substantial research on our own solar system. It will also carry out some difficult missions in the long run, including using the Event Horizon Telescope to image our galaxy's black hole. Webb was created with a mission lifetime of at least 5.5 years in mind. On the plus side, it can also last for more than 10 years. We'll have to wait a bit longer to see the telescope's amazing photographs, but its bucket list of observations suggests that the wait will be well worth it.